welcome to the second episode of The Weekly Pleb. I'm your host, Douglas Rieger. Thank you for tuning in. Today I had a fantastic conversation with my good friend Ramon Neira. Ramon is a biomedical engineer from Northwestern University, and we're going to talk all about genetic modification for crops, the future of the agriculture industry, and even discuss genetic modification in humans. GMOs are pretty much harmless, but some of the ways that the technology is progressing can seem a bit scary, so Ramon is going to help us unpack all of it. I want to apologize for a couple audio glitches in this episode, but please bear with me, I'm still pretty new to this stuff. This interview ran a little long, so let's get right into it. It's my great pleasure to introduce our guest expert this week, biomedical engineer from Northwestern University, Ramon Neira. How are you, Ramon?
I'm doing good, buddy. How are you?
I'm doing just fantastic.
Good.
So why don't you go ahead and tell us what it is that biomedical engineers really do?
Yeah, so I study, like you said, at Northwestern, which is just 12 miles north of Chicago. And biomedical engineering is, I would say, the crossroads of medicine and engineering. So anytime you think about any kind of medical technology, right, like be it MRIs or stents or pacemakers, anything like that, more often than not, those are developed by engineers because medical practitioners don't tend to specialize as much in medical technologies. They more specialize in the actual patients and the treatments, right? So biomedical engineers are really the people who are spearheading nowadays, especially most developments in the medical technological world. Yeah, and then another thing that biomedical engineers do now that's really prevalent and we're going to talk about today is regenerative engineering. And that has to do with basically healing humans in a more efficient and fast way.
Okay, so biomedical engineers aren't as worried about today's medicine, they're thinking about the future.
Definitely.
Okay.
And even though there's a lot of focus on medical technologies, biomedical engineers also have to really think about the users, right? The patients, and that's something that we take into very, very heavy account whenever we're designing any products. And so it's also a lot of client interaction, which I enjoy.
That's great. You're a real people person, I know that.
Yeah. Yeah.
So what is, in its essence, what is genetic modification?
So to talk about genetic modification, first you have to understand what genes are. And there's a really good analogy that I like to use whenever I talk about genes. I read this in a website. But if you think about it, genes are the storage of information of the human body, right? They're stored in chromosomes. We have roughly 30,000 genes. That's what estimates say, but we don't even really know the actual number. And those 30,000 genes individually can code for altogether 40,000 different proteins. And so the processes going on inside the human body are so complex, but genes are essentially the code that has the instructions for what's going to be produced. And to use an analogy, if you think of chromosomes as the books, then genes are the words inside the book.
Okay, so it's the code. It's the coding to how we
Right.
work.
So genes are the code. And so genetic modification is just taking the code and altering it, because even though the human body is remarkable and our DNA is incredible, there are still errors in the code. And so being able to edit it and make it better are things that are obviously of very high interest to the medical community.
Yeah. We've kind of been doing this already naturally, right? Without the medicine and the technology, we've
Right.
been, like, for example, breeding the best plants of each crop, and then continuously we have better versions of that plant, or like how dogs came to be domesticated.
Exactly. Yeah, exactly. So one thing that is I would say the biggest problem with genetic modification right now is the stigma around it in the general public. You know, people hear the term GMO and they run for the hills, or, you know, that's why there's such a big fad right now for organic foods. But in my opinion, like, and again, I'm not a specialist, but I really do think that it's kind of a a little marketing ploy to get people to spend more money on fruits, right? And
Yeah.
vegetables. Um, but yeah, genetic modification is not something new. Like people think this is something we just started doing. Like you said, like anything that involves picking what two specimens to breed because of a desired trait, in a way, is a form of genetic modification. Because even though you're not doing it to the individual, like subunit, like you're not doing it to a plant how you would change its DNA, you're picking the next one to be transferred, right? It's still a form of genetic modification in the long run. And so, like you said, with crops, for example, humans have been picking the biggest, potatoes as the seeds that they plant, the biggest apples, right? That's something that has been going on forever. And that's why the fruits keep getting bigger, right? And then, like you said, with dog breeding too, dogs used to be extremely skilled predators, right? And through selective breeding, we've in a way stunted their evolutionary growth. Pugs, for example, that's my favorite example because it's an animal that it's a species or a type of dog, a breed that originally was a pretty healthy kind of dog, and through selective breeding we've picked the ones with the smallest noses until they get to the point where their noses are literally flat now and they have breathing problems and they have just so many problems associated with that, but that's all because of humans, right? And I guess my favorite example, I mean, not my favorite, but just a really crazy example is the ancient Spartans. They were super hardcore. They were crazy. And so one thing that they
Yeah.
did is whenever they had babies that were born and they looked weak or like deformed in any way, they would just throw them off a cliff. They would literally throw them off this mountain.
Really?
Yeah, they would throw them off a mountain to kill them
They
because
would literally take the baby and go, "This is Sparta in Sparta" to the
exactly. And
baby. They
yeah,
were getting
yeah,
rid of these messed up babies.
exactly. And so,
That's
I
insane. So
mean,
that's already a form of genetic engineering then,
right.
because they're
It's not
choosing who gets to make it.
exactly,
It's
exactly.
not
And
natural selection.
it's not natural selection. Exactly. Yeah. It's artificial selection. Um, but I mean, that is, I guess you could say, the basis of modifying genes in a species. And I mean, you fast forward to where we are now, and we have now, I think the most well-known and kind of significant piece of technology is the CRISPR technology, right? Which,
Yeah.
to continue the book analogy, before what we had were methods that if you had to edit the code, right, that was a book, you couldn't go in and change the individual, because DNA is made of the base pairs, right? ACTG,
Yeah.
adenosine, cytosine, guanine, and adenine. And so what happens is, before, what we had to do was, if we wanted to edit a gene, we'd have to cut out the part of the chromosome that had it and then change it and then insert it back, right? And that was a very tedious and like difficult process to do, and it took a long time and it was expensive. And what CRISPR does, and so if you take the analogy, sorry, before I talk about CRISPR, if you take the analogy, that would be like if you're going to edit a single word in a book, you would rip out the entire page, fix the one word, and then put back the entire page in the book, right? It makes no sense. What CRISPR does is it
Yeah.
allows you to go into the individual genes and edit them one by one. And it's way cheaper and way faster. And so what ends up happening is now you can go into the book and just change the words that you want. And
Okay. And
so the
CRISPR is it's an automated machine, right? People
it's a
don't
machine.
really
Yeah, it's a
like.
machine. Yeah.
Okay.
I
So
I
people aren't
actually
that involved with how it works.
Yeah. So, um, again, I'm not a specialist and I've never used the technology. It's pretty rare to use it at an undergraduate level, I would say. And especially because there are a lot of like ethical dilemmas around it, and I'll touch on those in a bit, but it's just not a very common thing to do unless you're very,
Yeah.
very specialized in the field. Um, but I would say the biggest implications of CRISPR right now are the fact that it allows you to target individual genes, right? And so there's a lot of diseases that are classified as monogenetic diseases, which means they pertain to only one gene on the chromosomes. And what that means is that if you could essentially find a way to flip the gene the way you want it, you would have no problem. And so like some of these examples are like cystic fibrosis, sickle cell anemia, Huntington's disease. And for Huntington's disease, I have a note that um, I think that it's something that could be potentially treated with Neuralink as well,
Okay. So
because
that's
it's a brain disease. It's a disease of the nervous system.
yeah.
So yeah, but
Now we're getting into the chips in the brain.
right. And that's something that I also wanted to talk about if we had time.
Of
Uh,
course.
but the last thing I want to say, at least about CRISPR, is that people always think about the applications for humans, but there's so many other applications, and the biggest one, in my opinion, is GMOs, right? Because the clearance required to test on a vegetable is so much lower than the clearance required to even test on a mouse, for example, or to test on a human, right? And so
Of course. Of
the first thing
course.
I want to say is, and again, this is my like biased but scientific perspective, right? And I would say it's the perspective held by most people in the scientific community at large, right? Is that GMOs are not something to be afraid of, and there's something that should be explored. And to the listeners, I just want to say, like, no one's paying me to say this, you know, like I'm not out here pushing any agendas. Like, this is just honestly what I believe.
Ramon is not a shill.
Yeah,
Ramon is
yeah,
not a
yeah.
government shill.
um but with GMOs, what it allows us to do, we've already seen so many like amazing examples. We have golden rice, which is a rice where it was genetically modified to have higher levels of vitamins. And it was like a very simple process to do, but once we have it now, it can be distributed to countries where children are traditionally malnourished. And I mean, the applications of that are, they're only good. There's nothing wrong or nothing bad about that process, you know?
Yeah.
And like, I mean, especially one thing that I think it's going to be really prevalent for is feeding the huge population that we're going to have in 20 to 30 years, right? I mean, our population curve is just growing so fast.
Yeah, because theoretically, if we focus more on genetic modification of plants and our agriculture system, we could, instead of expanding and like planting a new land, always fighting diseases, we could make it so the agriculture doesn't need as much land, doesn't need as much water, doesn't need as much nutrients to be these massive, plump fruit that can feed the entire world, right?
Right. So a really good example of that is we have this corn that originally was one cob per stalk of corn, and through a genetic modification, we were literally able to just go in and flip a few genes in the corn, and we made it so that each one produced two, right? And so if you think about it, like just at a base
Doubled
level,
your output.
right, you've doubled your output and your area remains the same. And so
Yeah.
just in terms of that, that's a really like simple example of doubling something for very little added cost. You know, it's going to probably require more water, but still less water than if we were to double the field of land. And so
Yeah, of course.
I really do think that it's something that should be explored, like, because the thing is, the way GMOs work, it's you're changing the genetic code. So when you do that, you know what genes you're changing, right? It's not like you're gonna change a gene and be like, oh, I don't know what's gonna happen with this, and we're gonna see what happens, you know, like, and it's not like suddenly by
It's not
flipping it,
really a guessing game.
right? And it's not something that is gonna be like super dangerous to people, you know, like it's not gonna be like they're filled with like chemicals and stuff, right? I think a way bigger problem is the way a lot of agriculture is like sprayed with pesticides and insecticides and stuff, and the fact that those are really harmful chemicals. You know, that's not something that you get with GMOs, because you can even make GMOs that are more resistant to like bacteria and viruses, right? It
Mhm.
might not necessarily be more resistant to like traditional pests, but it'll definitely be more resistant to bacteria and viruses, and that's also really important for crops. So
Yeah. And I mean, pesticides on the plants, doesn't that usually get like farmers sick and stuff like that?
it can get, dude, it can get farmers sick if it gets into water supplies. It can get other people sick. Like it's crazy. Like those those chemicals,
So
there's so many bad ones that they get approved without knowing the full effects of them. So yeah, no, I definitely think that that's a problem.
yeah. So let's go back to Neuralink. So
Yeah,
because you
let's go somewhere fun. Yeah.
so Neuralink isn't really genetic modification, right? Because that's like going in with the really thin wires, like I think it's 100th the size of a human hair that they're put wires that they want to put in the back of your skull, and then they'll be able to control certain nerves to stop things like seizure, epilepsy, like you said. You mentioned some other diseases you think
Huntington's
that it could
disease.
attack.
Yeah. Yeah. So
Yeah,
so
even Alzheimer's and stuff like that.
right, right. So the first thing that I want to say about Neuralink is that even though like I honestly do believe in Elon Musk, like, and I do believe that it's going to be safe, like with all things that are like very medical like that, you have to make sure that you understand all the risks, because oftentimes with things like that that are very revolutionary, uh the risks and the long-term implications aren't fully understood. But again, that's something that it's on you to do the due diligence and understand the risks and undergo such a big procedure. But
Said that you kind of have to know the risks, like, okay, I'm doing this surgery, there's going to be a chip in my brain. There is the possibility of like a dark future where like Elon turns evil, everyone's got the chip and he flips a switch, right? But
yeah,
what my thinking is, if a lot or a good portion of society starts getting these chips for medical reasons or eventually enhancement reasons,
mm-hmm,
like I feel like there's going to be pressure that you kind of have to have it or you can't really keep up, right? Because
exactly. Yeah.
it's a weird thought for me. I feel like in order to keep up, I would probably be willing to get the Neuralink, right? But
Well,
at the
like,
same time, if I had kids, I don't want to put anything in my kid's brain if I had
right.
kids. You know what I
And
mean?
what I'm saying is like
So
even think of the like heavy societal pressure people feel nowadays. If you're in a group chat and you're the reason the text bubble's green, like, you know what I'm saying? Like things like that.
yeah,
You
yeah,
don't have like,
yeah.
it's just there's so
Oh,
much.
you don't have the new iPhone? Yeah,
Exactly.
you don't have the new Apple Watch.
Right.
You don't got the new Neuralink. You don't have that. Yeah, yeah,
um, but
yeah. I'm waiting for the day that I'm walking down the street and I see someone with it on the back of their neck.
yeah, yeah. We see them like running on the walls and jumping through like 4 blocks at a time. So
Just like next year. No, but so realistically, what do you think the chances of like that technology developing soon or whenever?
so so here's the thing. The human brain, at the end of the day, what it comes down to is just nerves. It's just brain cells. And
And meat.
it's yeah, and meat. But the communication that goes on within the brain, the actual like signals that go through are all electrical, right? There's also like neurotransmitters, things you hear of like epinephrine, adrenaline, or that's not adrenaline, but like, just all the traditional dopamine, serotonin, all those neurotransmitters that you hear of. So
I like dopamine.
those are released. We all do, buddy. um, but those neurotransmitters, they're released in response to electrical signals. So at the base level, every single signal sent within the brain that's going to communicate a function is an electrical signal. It's exactly like a computer, right? Even though the
Yeah.
computer can have like lights and diodes and buttons, at the end of the day, everything that goes on within its communication is electrical signals. And so the electrical kind of circuit ways and paths of the brain are actually pretty simple to understand because we have very good like imaging technology, and we're able to track those electrical currents pretty well. And so the problem that Neuralink is trying to address is that there's some diseases that lead to errors in the communications or the functions of the brain, right? Even certain parts can just get to the point where signals don't come out or don't go in. And that part essentially
Yeah.
becomes like a dead mass in the brain. And so what Neuralink does is it's a little chip, it's a little computer. And like you said, it has the tiny, tiny little wires that go to individual regions of the brain. And one thing that's also interesting about the brain is that it's very organized, right? The organization is hard to understand, but there is a method to its madness, right? So examples of this are like people who have been in accidents where a certain region of their brain is destroyed and they lose certain functions, right? The brain is crazy. Like, for example, the right side of the brain is responsible for many activities of the left side of the body. That's because there's these things called decussations in the spine, which is where nerves cross over from the left to the right or from the right to the left, and they transfer. And so I was reading about why that was, and it's kind of misunderstood, but they seem to think that there was a 180-degree rotation in like the orientation of the body. I don't really understand what it means, but yeah,
Like
it's crazy.
through evolution, at some point, someone just had
Right.
their head on backwards, like Pennywise or whatever.
Right. And but anyway, what it leads to is the fact that with these little currents, we can stimulate areas we know aren't working, right? So for example, if someone's left arm is paralyzed, we can trace the pathway from the motor neurons in the arm to the brain and see like what's going on here.
Wow. I had seen all this stuff that was like, I don't want to say anti-Neuralink, but kind of saying that, oh, it's never going to happen, not in our lifetimes. And their argument is basically that scientists and doctors have been trying to like fully understand the brain for decades, and they still kind of are a bit lost because it's more complex than any computer we've ever made.
Oh,
Right.
dude, it's infinitely times more powerful than any computer we've made, and it's complex. The problem is that the processing speed isn't as fast as a computer, right? But
Not at all.
but in terms of
nor the RAM.
right. But in terms of the like, I want to say like the computational spectrum that we have, right? We can't go as fast as computers, but computers can't process things like emotion the way we can, right? A computer can't love the way a human can love. And so that's a form of processing that is unavailable to computers right now. I don't know if we're going to come to the day where humans and robots fall in love. But
who knows? You have these people dating body pillows and stuff. That's the next step.
Yeah, right. People, I mean, I saw this guy the other day on the news who I think he married his boat or something.
Yeah, see,
I don't even know.
There's all sorts of kinds of people for whatever kinds of things.
Right.
So what's your timeline? When do you think you could walk down the street and catch somebody wearing a Neuralink?
I mean, here's the thing. The anti-Neuralink people, I'm not sure they're hating on the existence of it. I think they're more hating on how fast Elon claims this timeline is going to move. Yeah. And in that respect, I honestly agree with them because, like I said, the human brain is extremely complex. Like, we can understand what certain parts do, but like, first of all, we don't understand every single part of the brain yet. It's not like we can point to any part of the brain and say we know exactly how this works and what it communicates with. Like, we have a good understanding of a lot of things, but there's also a lot we don't understand. And another thing I want to kind of dig deeper into Neuralink, because I'm obviously no expert, but I want to understand how they can process intent, right? Because here's the thing. Let's say your arm doesn't work, right? Before you have to move the arm, your brain has to decide that it's going to move it, right? So, like, call it your subconscious, call it your soul, whatever's inside of your brain, that voice, it tells you, I'm going to grab this pen, right? Mm-hmm. How are you able to transfer that raw input from, wherever that's coming from in your brain to the Neuralink chip to then the arm, right? And so that's something that I don't understand. And another thing is that whenever Elon talks about Neuralink, he talks about it very nonchalantly, like it's a very simple thing to understand. And I understand that's how his brain works, and he always tries to simplify things down. And I'm a huge Elon fan, by the way. Don't get me wrong, I'm a huge fan. But I just think with Neuralink, it's different. It's not a car that you can like road test it at as many times as you want. It's not a rocket that, at the end of the day, if you're doing an unmanned flight test and it breaks, all you've lost is money. You haven't lost lives. You haven't ruined, you
Yeah.
know.
Yeah.
But the implications of messing up Neuralink are crazy because it's your brain. And anytime you mess with the brain, the possibilities are literally endless.
Yeah, and if they did, once they get to human testing, if they do, that one fatality or one mistake could like crush them. I feel like that's why they have to try and perfect it before they get to that stage.
Exactly. I mean, they're definitely gonna have to test it on many animals. I think they said they got it working in mice, but
He had a whole what do you call it? Like a showcase thing during the pandemic, like in August, I think.
oh wow,
And he had he had some pigs, and one of them had it for like a year or a few months or something, and didn't have it anymore. And one currently had it, and they were feeding the pig, and every time the snout touched the food, you could see the live signal from the Neuralink in the pig's brain, like
wow,
beeping because it was connected to the snout.
oh
But
wow.
I mean, it was kind of it's kind of confusing because like honestly, what the hell does that mean? Like, oh great, we know when the pig snout touches something,
Right.
but like
Well,
it still was pretty cool to watch. It was interesting.
no, it's definitely, and that's good. That's any progress is good. Like any progress is good. And again, they're like this is pretty well understood, but the first, I think Elon said like 10 generations of it are going to be purely medical, like fixing what's wrong,
Yeah,
right? Um
and then we get the automatic music in your head without headphones,
then we get the Cortana in your head at all times.
and the telepathy and everything else
Right.
involved. Yeah,
You know. Um but no, I think especially not just with Neuralink, but also with like genetic modification and CRISPR, where it's going to get to the point where, you're going to be able to design your baby how you want. You're going to be able to say, like, okay, I want my kid to be this tall, be
yeah,
this smart, and with those technologies, all those technologies that are seeking to not like bring you up to normal, but to push you past the level, the population mean, what makes you better. Um,
yeah,
there's the concern and kind of the reality that it's essentially at first going to only be available to the hyper wealthy people, right? And so because of
yeah,
that, there's always the possibility that they just get so much time, such a head start with it that they have, let's say, 4 generations advantage of genetically hyper intelligent
yeah,
children who then from
yeah.
their hyper smart genes you're picking the smartest of those, and from those you're picking the smartest, and it's the same thing as the dogs, and you suddenly end up with like a family of
Yeah.
Albert Einstein, Thomas Edison, Leonardo da Vinci all at once,
The biggest concern for me with that is you said it exactly, is that most average people may not be able to afford to have designer babies like that.
exactly.
They can't design Superman like everybody else.
Right. And so that's gonna, I mean, you talk about the wealth gap right now. I think everyone agrees that's a problem. And then you think about what happens if the rich not only get richer, but they get like
Smarter.
significantly smarter and faster and healthier. They live longer lives, they pass
Yeah.
on more knowledge. It's gonna create almost a, I don't even know. It's going to create a divide like never before because it might even like lead to the point where we're almost perceived as different species, right? Where
Well, that's
like
kind of Elon's plan with Neuralink, isn't it? That he kind of wants to evolve humanity essentially. Which this isn't Neuralink. This is honestly genetic modification of kids and designer babies. Sounds much more realistic to me in the short term than
yeah.
Neuralink.
Well, because the thing is like to make Neuralink work and progress humanity as he says, you'd have to put it in a lot of people. You would have to like make it so that everyone is getting this chip in their brain. Whereas if we perfect genetic modification to the point where it becomes like cheap to go to the hospital and make sure your child isn't born with any diseases,
It'll happen anyways. Like it'll
it'll be
just
like
spread.
exactly, it would be like an IVF. Like how they have in vitro fertilization now where they take the sperm and the egg out and they make sure that it's not going to have any diseases before they fertilize the mother. It would be like that, but with a few extra steps. So add a few more spices in there.
There are diseases that they could look for during the pregnancy, right? And they can choose to abort a pregnancy because of genetic defects that they can tell are wrong with the baby. So we're already doing this stuff.
Right. Like it's very easy to tell, or I shouldn't say it's very easy, but it's pretty well understood the process of how you go about seeing if your child has a genetic disease, especially a big one like, for example, Down syndrome, where the change is literally an extra chromosome. At that point, it's something that you know how to identify, and once you see it, you know what it is, right? And so with things like that, you can definitely look into that and find out ahead of time, and then that becomes a whole ethical conversation that, I mean, anyone could spend hours on talking about if it's ethically correct to abort a fetus because it's going to be, you know?
Yeah. But then eventually it'll turn around to the point where, because of genetic modification, for example, we can essentially immunize, is that the right word? We can essentially immunize the babies.
Immunize?
Yeah, immunize. That sounds wrong the more I say it, but you could give vaccines to the young babies or whatever genetic modification to prevent them from having, let's say, cancer, right?
Right.
And then
exactly.
at that point, if we have that technology, then it could be arguably unethical to not do it.
Exactly.
Not prevent this baby from getting cancer.
Exactly. And I do think we will reach that point at some point. I don't know if it'll be during our lifetime, but I do like to think that regardless of everything political going on in the world, yo, give me a sec. What's up? I'm on a podcast. Oh, what's up, my bad? Fuck, what was I saying? In the long term, like the scientific community does tend to prevail with their discoveries, right? I know there's always like those conspiracies that someone has the cure for all diseases or cure for cancer and they get killed by the government, right? I don't know about the legitimacy of that, but what I do know is that whenever there are very, very like powerful technologies, more often than not, they do become available at some point to the wide public. Like, I mean, even just think about the fact that when ultrasounds first came out, it was a huge thing, it almost occupied an entire room, right? And the transducers to create the sound waves were huge, and they were made out of like terrible materials. And now we have ultrasounds that you literally control with your hand, you know? You can see if there's a baby in someone's stomach, you know?
Yeah, or like how iPhones are more powerful than the computers on the Apollo missions.
Oh, right. No, dude, TVs, flat screen TVs, when the first flat screens came out, I heard they were something like $10,000.
Yeah, yeah. And now it's like a couple $100 at Costco.
Yeah, dude, I'm not kidding. I saw a 65-inch TV at Walmart for $400. Like,
killer deal.
also, I do like to think that these technologies will be things that will become available someday. And I think the biggest motivation behind that is that as a government, why wouldn't you want a healthier population? You know,
Yeah.
why wouldn't you want to lower your like healthcare costs, your at all costs? Because, you know, the biggest thing like that I've honestly taken away from my time at Northwestern in biomedical engineering is that no matter how much you pound away at a medicine or a cure for something, like there's no replacement for preventing it in the first place, right? And that's the biggest problem we have in America right now is that unfortunately our population is like very obese, and obesity is literally the number one killer. It's because it can exacerbate so many other conditions, right? Like if you're obese, it can increase your chances of cancer in certain parts of your body. It increases your chances of heart rate. And so like it creates a big strain on people's lives.
There's an argument in economics that basically says if you have the power to prevent human suffering, then morally you kind of have to. You know, if you can prevent something bad from happening, then we should do it. So that's why I feel like the technology is definitely it's happening now.
Oh yeah, definitely. And well, the last point I just wanted to make is that when I said preventative and what I was talking about is just the fact that, like, I mean, I'm not someone that would ever judge people by their size of their body or anything. But just from like a purely statistical standpoint, how many like hyper obese people do you see walking around at 80 years old?
Yeah, exactly. I mean, I get
Very
it.
few.
I think it's funny how you think about the original, like early medieval times. Who were the fat people?
Yeah.
Like the king, right? Because he
Well,
could
you were
afford.
fat, you were powerful.
Yeah,
Right.
you could afford to eat well, and the peasants were skinny. But now the roles have reversed because the rich people can go to their Whole Foods and eat all organic, vegan, whatever the hell they want. And
Exactly.
then most people
Exactly.
that are working paycheck to paycheck got to stop at McDonald's on the way home, right?
Exactly. That's what I'm saying. And that's why I always try and as a general rule, I never try to like look at things in the past and say like at least societal norms in the past and try to justify them or like try to like emulate them and take them as like, oh, this is good. Like humans are meant to be fat because that's what we did in the medieval times. Whenever I look to the past to try and understand how we are, I usually tend to favor looking towards early cavemen, early man, just because I feel like that's when the evolutionary development was at its peak, right? When we finally became like Homo sapiens, very intelligent men. You know, humans would go multiple days without eating because they were hunter gatherers, and so they would kill an animal and then they would eat it and then they would go like 3 or 4 days hunting for without eating, hunting for a new one. And the craziest thing is that now we're finding with all these new studies on like different kinds of fasting that when you're fasted and you're kind of in a state of not starvation but just a little bit of a heightened hunger, what actually happens
Yeah,
is your brain becomes sharper, you become more focused, you think more clearly. And the reason why is because from an evolutionary perspective, when early men became hungry, they had to sharpen their skills to get the kill, right? They couldn't afford to have their stomach grumbling and their mind foggy, right?
yeah,
And
that
I
makes
mean,
sense.
nowadays, the food industry has honestly, I think, just kind of perversed our notions of nutrition in the sense that they've taken things like high fructose corn syrup and put it in every single thing we eat. And I really think that that's an attempt to obviously make the food taste better and
Addictive.
probably cheaper to make. But the the byproduct of it is that it's literally killing millions of people a year, you
and
know?
it and it's addictive, right? It's habit forming to
It's
eat this kind
addictive.
of
No,
food.
it's
Yeah,
addictive as fuck, dude. It's addictive as fuck. Like people nowadays, if they try to like really limit their diets to healthy things, it's very hard for people. Like, and I'm not saying like I can do it super easily because I can't, you know. I
yeah,
get super tempted to eat junk food too. I think that's just something that happens as a
it's,
byproduct of these like addictions we've created
yeah.
to the food we eat.
Well, it's our parents and grandparents for eating Twinkies and shit like that, right?
Right. You know, and we can't blame them. They
No,
didn't
I know.
know. They didn't know any
No,
better.
I know. Luckily,
uh,
we know better, right? So
yeah, no, definitely. Definitely. Go for a run, eat healthy. Like, I'm not saying you got to kill yourself at the gym, but I'm saying like just, treat your body with the certain respect that you want to look back when you're 80 and say, I'm glad I'm here because I took care of myself, you know?
Definitely. Awesome. Well, Ramon, thank you for coming on. It was awesome talking to you.
Thanks for having
I've
me,
been looking
buddy.
forward to this.
Yeah, for sure. I'm excited to see you again soon.
Yeah, dude, I'm looking forward to the next one. I'm gonna think of things to talk about because I have a lot of ideas.